Welcome to this episode of AI Frontiers, focusing on the robotics revolution, AI-powered machines in action. This synthesis covers 27 papers from October 15th, 2025. The discussion delves into the latest robotics breakthroughs, exploring how AI enhances robots to be smarter, more adaptive, and prepared for real-world challenges. Today's focus includes innovations from perception to locomotion and beyond. This presentation offers an overview of unraveling cutting-edge advances in robotics. An exciting journey is presented through 27 fresh papers in computer science robotics. Key themes, findings, and future potentials are explored in an engaging, story-like narrative. This content is ideal for researchers, enthusiasts, or anyone curious about how robots are reshaping the world. Insights are provided on how machines are learning to sense, plan, and interact like never before. An overview of the field is now provided. Computer science robotics combines AI, engineering, and control theory to create intelligent machines. The focus is on perception, planning, manipulation, and coordination, enabling robots to act in real environments. Applications span manufacturing automation, healthcare assistance, and exploration in hazardous areas. These 27 papers highlight shifts toward adaptable, AI-driven systems for everyday use. The first research theme addresses sensory integration and multimodal perception, fusing senses for better robot awareness. A key aspect is combining vision, touch, and language to enhance robot intuition, similar to how humans infer texture from sight. In the work by Wu et al., virtual tactile feedback is generated from images for precise pushing without physical senses. Li et al. Predict forces in produce handling using piezoresistive sensors for safer manipulation. Gordon et al. Enable active tactile exploration for estimating object poses and shapes. This theme addresses gaps in single sensor reliance, improving efficiency in dynamic tasks. The second research theme covers planning and control in uncertain environments, optimizing actions amid chaos. The focus is on robust planning for disturbances, such as stabilizing drones with swinging loads. Das et al. Use partial feedback linearization for cable-suspended multi-rotor stability. Liu et al. Insert skills via optimistic reinforcement learning for complex task planning. Zhang et al. Apply diffusion models for parking in confined spaces. Blending learning with optimization. Reinforcement learning here is defined as a trial and error method where robots earn rewards for successful actions. The third research theme examines learning-based approaches and robustness. Part 1. Teaching robots through data and adaptation. Emphasis is placed on imitation and reinforcement learning for adaptable behaviors in real-world scenarios. Stasica et al. Train quadrupeds on oscillating surfaces using simulations for zero-shot real-world transfer. Bocello et al. Enable pro-level drone racing without GPS, inspired by human pilots' instincts. Chen et al. Develops spatially guided models for following language instructions in tasks. Domain randomization, which involves varying simulation parameters, helps bridge virtual training to physical deployment. Continuing with the third research theme, learning-based approaches and robustness, Part 2, scaling to multi-robot and human interactions. Learning is extended to teams and interfaces for seamless collaboration. Li et al. Optimize adaptive task assignment for heterogeneous robot teams in obstacles. Morris et al. Plans spatially intelligent patrols for swarms localizing emitters. Barrett et al. Create intuitive GUIs for non-expert teleoperation of humanoids. Guo et al. Design modular hands for self-adaptive grasping in constrained environments. Key findings from across the papers are now highlighted. Vision-to-touch generation achieves 86% success in pushing tasks, reducing sensor costs, as shown by Wu et al. Autonomous drones match human pilots in uninstrumented arenas, advancing navigation, according to Bocello et al. Spatially guided models boost instruction following by 20% for unseen objects, per Chen et al. Efficient 3D mesh reconstruction from LiDAR cuts data size by 10 times for real-time mapping, as detailed by Wang et al. Under-actuated hands enable versatile grasping with one actuator, simplifying designs, from Guo et al. Methodologies synthesizing common approaches are discussed. Reinforcement learning involves trial and error training with rewards, strong for adaptability but data-intensive. Optimization-based planning uses algorithms like differential evolution for efficient paths, reliable but less flexible in uncertainty. Simulation and digital twins provide virtual testing for safety, enabling zero-shot transfer despite sim-to-real gaps. Sensor fusion blends modalities via contrastive learning for robust perception, though computationally heavy. The first selected research paper is ViTac-Gen, Robotic Pushing with Vision-to-Touch Generation by Wu et al. It is selected for its novel impact in perception, enabling affordable manipulation without tactile hardware. The objective is to simulate touch from vision for precise object pushing, inspired by human sensory inference. The method employs an encoder-decoder network that generates virtual tactile images fused with reinforcement learning. Findings show 86% real-world success with generalization to new objects and surfaces. Significance includes lowering costs for logistics bots and advancing multimodal AI with zero-shot deployment. The second selected research paper is Bridge the Gap, Enhancing Quadruped Locomotion with Vertical Ground Perturbations by Stasica et al. It is chosen for representing locomotion robustness and sim-to-real innovation in uncertain terrains. The objective is to train quadrupeds for stable gaits on oscillating surfaces like bridges. The method uses proximal policy optimization in simulation with domain randomization for direct hardware transfer. Findings reveal 40% higher success rates with adaptive control preventing falls. Significance boosts reliability for rescue and construction robots, drawing from bio-inspired strategies. The third selected research paper is Intern VLAN1, a spatially guided vision-language action framework for generalist robot policy by Chen et al. It is selected for its novelty in generalist policies, enhancing human-robot interaction through spatial understanding. The objective is to improve instruction following for tasks like picking objects based on language commands. The method involves a two-stage pipeline with spatial grounding and contrastive learning on large datasets. Findings indicate 14.6 to 20.6% performance gains with strong generalization to novel scenarios. Significance enables intuitive collaboration in warehouses with open-sourced code for broader adoption. Future directions in robotics research are explored. Hybrid methods combining learning and classical controls are anticipated to minimize sim-to-real gaps. Ethical frameworks for safe human-robot interactions and scalable multi-agent systems are emphasized. Edge computing for real-time decisions in swarms and modular designs for on-the-fly reconfiguration are highlighted. Challenges like data efficiency and robustness to novel perturbations must be addressed. The AI synthesis and review process is described. This synthesis was created using AI tools including GPT-Grok using model Grok 4.0709, TTS synthesis using OpenAI, and image generation using Google. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All the references are provided. Subscription and channel information are provided. Subscription to the YouTube channel is encouraged for more insightful episodes on cutting-edge research. The title is AI Frontiers. The description is not fully detailed here, but viewers are urged not to miss out. Hit subscribe and turn on notifications for the latest in AI and robotics. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.